Hello everyone! These couple of next videos will provide a way for everyone who is willing to get into automation a stepping stone. This first example will be about starting and stopping an induction motor with cage rotor. In this case, I will call it motor M1. To make this motor start turning, we need to connect it to a 3-phase power supply. Once connected, the motor will automatically start to turn. Now we will design a simple control circuit step by step. Firstly, we need a neutral wire because the control system uses one-phase 230 volts AC current. Next, we will need to add a contactor coil in the control circuit. This coil will be called K1, and the other end will be connected to one of the phases. By doing this and also adding the main normally open 3-pole contacts to the schematic, once the simulation is started, the coil will be energized and switch over the contacts of the contactor K1, therefore starting the motor. But we don't want that. We want to start the motor with the press of a button. This button will turn on the motor, but for it to stay on we need to hold the button, which is a problem. To circumvent this, we add an additional or auxiliary normally open contact that is connected to K1 and therefore will ensure the coil stays energized even though we pressed the button only once. It works perfectly. Lastly, we will need to add a button that will stop the motor. Pay special attention to the contact of the button. These buttons are always normally closed, while the ones for turning on are normally open. Finally, we have a working control circuit that can turn on and off an induction motor. And now I will show you the full schematic for this circuit with some additional devices for protection and signalization. Firstly, we have 3 phases, neutral and ground, a disconnect switch Q1, and a connection terminal X1 for protective earth. Then a 3-pole breaker of 16 amps, and also 2 6-amp breakers for a control circuit and for signalization. Then we also have a motor overload protection with 2 auxiliary contacts, one for control circuit and one for signalization. Then the rest of the circuit is very similar to the circuit from the first part of the video, with main contactor, motor, coils, contacts, buttons, only addition being the lamp for the motor error signalization. Two contacts used for overload protection are normally open and closed for the fault and running. As when the protection trips, it will return to a closed position and turn on the lamp, signaling that there is a fault. And that is a full design. If you enjoyed this explanation, leave a like. Thank you.